Okay, so I guess that's it. So, today I'm going to tell you about MLOps with Amazon SageMaker, and later today you're going to have a workshop which is called From Idea to Production in 6 steps, and this session is somewhat complementary to it, so you will know like what the big picture is, what is MLOps, and let's start, with a simple question. Who of you like working with machine learning or AI in your day-to-day job? Okay, 1, 2, 3, 4, 5, 6, 7. Well, we have 10 people. That's not so bad. This picture tells a lot about machine learning. So machine learning is a quite odd thing, sometimes like on the edge with magic. But it's not magic. The problem with machine learning is that it's quite complex and is quite cycled, and you always have to do something. So, and MLOps is the field of how you operationalize this machine learning flow. So, every machine learning task starts with a design. Then something happens and you receive the model. The problem comes when you have to put this model into production and operation. So, almost no one do it correctly, and it always causes you lots of trouble. So for that, we have MLOps on AWS with a SageMaker. So let's first maybe discuss what besides of MLOps we have on AWS about ML. So first of all, of course, we have generative AI. We have Amazon Bedrock, which provides you access to different kind of models. We have Amazon Q, and we have Amazon SageMaker, which is basically IDE for ML development. We have bunch of high-level AI services like Comprehend for text analyzing, Personalize for recommendations, Transcribe, Text Tract, and others. Then we have specific ML services for MLOps and ML development, which is SageMaker and Canvas. And of course, we have lots of different infrastructure like virtual machines with our own neuron chips, and support for almost every framework you may know. Of course, we have lots of NVIDIA graphic cards you could use. Not so bad. But let's start with SageMaker overview. So, as I said, SageMaker is an IDE you can utilize on the full cycle of machine learning. And machine learning cycle, of course, starts with a data preparation. After you prepared your data, you do the build of the model, then you train and tune it, and then you start to deploy it. So one good thing about SageMaker that all these cycles can basically be done without any code. So for example, you have data wrangler, which allows you just point and click any data pipeline. Then you can use prepared algorithms from Jumpstart. You can do managed training and after deploy. But of course, that's not what you usually need. And all of this stuff can be like cut into 2 pieces. The first one is build. So that's the process of how you build your models. And the second one is operate of those models. So what happens after you put the models into production? So now let's see the ML development process. So first of all, of course, is machine learning code. So you have created a model, and now what else? So you have this ML code. Can anyone name any other steps of machine learning development cycle? Model training, yes. What else? Preparing data sets, yes. Data processing. Yeah, model testing, correct. So basically, yes, there are lots of other different parts. And which of those you think takes most of the time for data scientist or machine learning engineer? What's your guess? Training. Maybe it takes like a lot of the time like compute time, right? But in terms of human efforts and in terms of labor needed to complete this part, training is actually, I would say, the most easy part. Yes, data exploration and data preparation. So data collection, data preparation, and data verification takes up to 80% of all of the time of machine learning development cycle. And all other stuff, I mean, it exists, it's also important, and most of the time it doesn't take so much time just because nobody do it. Right, so the typical situation for the most companies in production is just schedule Jupyter notebooks. So you may think that it's like somewhat grotesque picture, but I can assure you that most of the companies just create a Jupyter notebook and then they create a cron job to run it into production, and that causes lots of problem. So that's why we have like you can call it a framework of 3 main steps how you can take your model from the ideation phase, which is the first one. And on this stage, you have to like answer on question what and how you can, which problem and how you can solve with ML problem, right? Then you have to pick the model itself. You have to understand, do you at least have a data for it? You do your research, you create your test models, you do some code, you train, you try, and all of it happens in your notebook. But the problem is how you will remember all of that. So on the automation phase, let's say you somehow remembered all of this stuff, and next step, you have to automate this, because when the model is trained, it actually have to bring the business value for your company or for your own or for, I don't know, some public sector. And that's how automation starts, because you cannot like run model every time. So you have to understand, does your approach scale? You have to understand, will your model be actually work at scale? So for example, some models are just cannot be scaled, and there is no way you can put it into mass production. So you have to ensure that your model will give same result on the same input data, because it's actually not guaranteed in the general case, and that's what you have to do as an ML engineer. So you focus on auditing and automation. You do some pipelines, you do jobs, and from those notebooks and scripts, you start to move to more advanced SageMaker concepts such as jobs, pipeline, you start to use model registry. All those pieces I will explain to you later, but that's how your workshop and basically any workflow with AI ML workloads look like. And of course, you add a model building CI/CD pipeline. So after that, you start the productization. So even if your solution is automated, it's still not ready for production. You have to ensure consistency and output results of your model. You have to do some A/B testing. I believe most of you do A/B tests on your production workloads, I don't know, on the product, right? So you testing, you do canary releases, maybe A/B and so on. So you try on different features. So that's same for the models. You have to understand how you will handle tough cases, like how you will do high availability of your model, how you will do resiliency of your solution, and so on. And here, And here, you, of course, focus on monitoring of data and the model itself. You do some event-based stuff. So you like finish up your solution. So why do you need it? Why? So basically, here are a few things you have to understand. So when you train your model, right, you train your model on some subset of data. So for example, if you You basically know ChatGPT, I believe, right? So ChatGPT, as you know, it has a cut-off on the data. So it contains only data to 2023, I believe, maybe now, like beginning of 2024. Why does it happen? Because the training of the model takes around 3 months. And basically, when you start to train your model, you cannot feed the data from the future to your model. So you start training, you train it for 3 months, and in the end, when it's done, it's already outdated. Most of the model also biased. What does it mean? That means that because of the data available on the internet, it creates, let's say, incorrect perception to the model of our world. For example, if you just gathering data from English part of the internet, right, which speaking on English, and there are some few parts on other languages, and then you will ask your model, like, okay, what's the most popular language on the internet? It will say you like English, no problem. But the problem is that it's not that. So it's probably some Chinese, I would say, or maybe Spanish, but because the model is biased and the data it has, like in the beginning is incorrect, your model will give biased and incorrect results. So your model may be broken, so it just trained wrong, or maybe you have something wrong with data, and that's why you always have to do A/B testing. Your model could be hacked. So for example, if I'm some smart guy and I know you train a new LLM and I want to do sophisticated attack on your company, I could poison your training data, right? So I add some malicious data in your training data set, and after that you train on my poisonous data, and then every answer for those questions which I fixed on the trained data will be attacked, so the answers of the model are going to be wrong. And of course, you always have to work on your model speed, quality, so it shouldn't be slow. I mean, slow have to be defined, what is slow for you, what's not. And all of it, of course, has to be monitored, has to be automated, same as we do with classical software development. So all of that automatization actually starts with containers. So containers now is not only in general compute and general purpose systems. All of the machine learning is also based on containers. Just because it's so much simpler, so much convenient, and everyone used to it, so everyone knows container. That's why ML also use it. It's portable. It's can be repeated easily, it's flexible, it's open standard, so you can create your own container, you can create your own machine for creating containers, and so on. I mean, it allows you to decouple, it allows you to take someone else's container, import into your Kubernetes cluster, which, for example, my colleague told you about today, and just use it. So, and this end-to-end based container experience is actually the most important thing which allowed us to build MLOps around machine learning, just because we also use containers. Just for your understanding how it is work. So in SageMaker, basic action with container, or let's say basic action, is a job. You have some job inputs, so that's your input data. You have the container, which runs on some ephemeral compute cluster, which is managed for you by SageMaker, and you send an invoke API signal to this container. It takes your input data, process it, do the inference, or maybe do the training, and put out the outputs. So in terms of code, those jobs are basically just JSON files with some configurations, some method attached. And in terms of infrastructure, as I told you, we have this VPC where we have SageMaker, and inside of it we have managed compute environment where you put your containers, and they take the data from different sources such as Amazon S3, Athena, Redshift. Also now, by the way, you can use, I believe, Databricks, you can use Snowflake, you can use your EMR cluster. So, and you even can, of course, because all of that is Python, just write your own connectors to any data source. Then your data processed, and the output goes to some storage like S3, Feature Store, or any other output data storage solution you may want to use. It's up to you. So now, finally, let's talk about MLOps. So the MLOps cycle, as you can see, consists of different parts. So first, we collect the data. Then we preprocess it. And engineer features. So these 3 steps, as I said before, takes actually 80% of your time. Then we train, tune, and evaluate our model. Then we deploy it. And after we have deployed, we start to monitor it. For every one of these steps, actually, SageMaker have some tooling for you. So all of the work, like the most abstract thing you have is a project which contains all of your stuff and allows you to use JIT-like version control system to actually describe all of that as a code. And then we have modules like SageMaker processing system. We have SageMaker feature store for the data feature engineering step. We have model registry where you can store the model you created. We have model monitor, which allows you to actually continuously take telemetry from your models and analyze it, do actions and stuff. And we have experiments, which actually allows you to keep track of what you're doing. So what basically data scientists do? If you don't know, I will tell you. So data scientists basically takes the data and try to get some features out of it. When he gets some feature set, he starts to try some models and hyperparameters for those models. So the model itself also have a set of different parameters you can tune. Then he writes some code. Then when the code written, he may try different framework versions or even different frameworks. Then he evaluates it. The problem with it is that you do it a lot. So that most of the day you just try different stuff on your SageMaker environment, and most of the time you're actually you try at it at luck. So you do some random stuff and you hope that it will help. So that's why you have to keep tracking what have you did so far today, yesterday, week ago, months ago. And for that, we have the experiment tracking. So all the code you execute, all the models you trained, all the data you processed is actually can be tracked with those experiments. And experiments, they keep track record of your data sets, right? They keep track record of your models. They keep track record of everything. And one of the most important thing, it's just not abstractly kept somewhere else. But for example, you took some data set, right? You did some processing on this data set, you created some features, and you trained a model in the end. So the killer feature of these experiments is that in the end model, you will be able to track actually this first data set and all of the actions you did when you processed them, which is called data lineage, machine learning lineage. And that allows you to understand what exactly you did with what data and what was results and how, for example, your actions affect the model performance. For that, in SageMaker, we actually have ML flow built in, managed ML flow. You just make few clicks, it arises, and yeah, you can track your experiments out of there. Previously, we had our own experiment tracking, but in the end, we just understood that everyone uses ML flow, so we discontinued our own code and integrated with ML flow, which is, I believe, was a good decision. So after experiments, as I said, you receive a model. So the model is basically a file. The model is a file with many different weights, like the graph with the weights and so on, or maybe some just parameters for equation. And it also have to be stored somewhere. For that, we have model registry. So you did the experimentation, and then you can place those models into model registry. Why is it so cool? Just because at this point you can actually split the responsibility between data scientists and, for example, MLOps engineers. Because data scientist his job just put the model into model registry. And then another engineer with different qualification can pick up the model from registry and place it serving, do some automated jobs, do some downstream services. So people who actually takes your models from the registry, they don't have to understand anything basically about how this model was created. It's very simple. For example, do you know Hugging Face? Yes, so the Hugging Face is the most popular and the biggest open model registry in the world. So when you take some, I don't know, llama free, download it from Hugging Face, you actually utilize the benefit of model registry. So someone else trained the model, put it on the Hugging Face, and you can use it without any knowledge of how it actually works inside. Here's some just stuff. Now let's go to pipelines. So the pipelines is a formal description of the cycle I've talked to you in the beginning. So this is just an example of ML pipeline. So let's say we have raw data, and then we do some data processing. After we did this processing, we receive training data. Then we do the training. We receive model. Then we evaluate model. And yeah, then we ask ourselves, is accuracy of this model is more than some threshold we set up, like 90%. If it's so, we can register the model, and in future we can deploy it and so on. And if it's not, we can go back to the data processing step, for example, and try something different. Or we can go back on model training step and tune some hyperparameters of the model, so which gives us some understanding of what we can do. So those pipelines are, of course, defined as a code. So first, you create steps. So for example, process data, then train, then evaluate, check, and register. Then we assemble those steps into workflow. The good thing is actually you don't have to construct the order of the steps by yourself. So the structure is actually created automatically. When you create a step and unite them into this, let's say, pipeline abstract object, it automatically understands which step can be done after which and creates this direct acyclic graph. And then you execute the pipeline, all of the steps, all of the jobs separated, executed separately. You are able to take out the metrics, you are able to take out logs, and if everything is good, it's lights green. If not, it's light red. So here it's how it looks in the code. You define parameters. You will see it in a workshop, those of you who are interested. So first of all, you define parameters, and because of the parameters, of course, you can automate that. Then you define steps, like here. So you just take a sklearn processor, you take some processing step, then you define a pipeline. And as I said, you can see that here, for example, steps, you give it just as a list. It's not an ordered list, not anything. And the system, because it's now the step types, it knows the types of input and output data, is able to construct this pipeline automatically. And then you just start it. You can do it in synchronous mode, in asynchronous mode. Usually, of course, you want to do it in asynchronous mode. You start, you go to take your coffee, and yeah, you wait. So the parameters is one of the most, I would say, interesting thing here, because it, of course, allows you to automate this. You can create quite abstract pipeline and then use them for different tasks, different models, and so on. So it's repeatable. It can be stored in your version control system, probably some Git-like. I doubt that any of you use Mercury these days. And then you can use CI/CD tooling like, I don't know, GitHub Actions, GitLab Actions, just to set and resolve those parameters in every case. So the pipeline can be either simple and complex. And as I told you, both of these actually created automatically. So all of those edges, all of those steps and jumps between states, they also create automatically. So yeah, don't worry if you don't understand it. I mean, you will probably on the workshop. So now let's talk about how DevOps applies to ML. So here is just a classic CI/CD ML DevOps stuff. So we have source, then we build the source code, we receive an artifact, and it's called continuous integration. Then we do test, and it's called, together with delivering those tested artifacts to production, it's called continuous delivery, continuous deployment. But only a few years ago, we actually started to apply all of those practices to ML. The problem is that ML actually have some additional steps and additional requirements. So ML requires you, your code, your data, your solution to be consistent. And it has to be same between different environments. It has to be flexible. It has to be reproducible, which is one of the most important, because if you train the model and it works inside AWS or, I don't know, inside your own data center and works differently in other environment, you can't use this model. It has to be scalable in some cases. It has to be auditable. That means that, for example, if you're working in some financial, insurance, banking, loans, actually in most of the states, there are some sort of regulator which will ask you to prove that and explain how your model, for example, do the credit scoring of your customers. And if you cannot explain it, and if you don't have the full transparency of it, you just cannot use machine learning models to do credit scoring, because you can, let's say, influence the loans market by giving bad, non-credible loan askers high scores, right? Give them loans, and then those loans gonna be not paid out, and insurance will have to pay you out, so you can influence market. That's why the audit of the models is a very important stuff. And in some cases, explainability, so how these or those results was created. So that means that on top of the classic DevOps stuff like code versioning, compute environment, continuous integration and delivery and monitoring, we have new stuff to implement. We have to do data provenance, we have to do data sets, automation, models, hyperparameters, metrics, and workflows. So all of that lies on top of the classic CI/CD stuff. So here you can see how the typical CI/CD for ML pipelines look like. So we start with some development and experiment. Result of our efforts is a source code. After we have this source code, we actually start to do the pipelines and split the source code to some jobs and receive, let's say, packages. Then those packages are gathered into automated pipelines, as I showed you with the jobs and other stuff. Then we do training. And here you can see continuous training. So continuous training is actually mean that you always retrain your model, for example, every day or every week, to be sure that it's actually takes in considering all of the new data. Then you deploy your trained model and you start to monitor it. Since you do continuous training, for example, some funny stuff can happen. Do anyone know what is data drift? Okay, so for example, let's say you are a startup and you do sell, I don't know, Pokemon cards. So you start small, you start selling them, and you see some patterns in your data. So you build a recommendation system for your customers, which propose them like the cards they may want to buy. After that, you started on a small market, you grow up, and when you grow up, you actually received lots of new customers, right? Lots of new data. And the problem is that your initial model is trained on the very small subset. For example, it's just, I don't know, Sweden people who use Pokemon cards. But then you scaled up on the whole European Union, and insights and the patterns inside of the model, which was true for a Sweden people, is just not will work for the whole EU. And this process of increasing of the data set and changing underlying dependencies and underlying, let's say, connections inside of your data is called a data drift. So here are like core components of AI ML, of ML CI/CD cycle. So we have a pipeline as a code, continuous integration, then we have continuous deployment of our pipelines, and we have automated testing, monitoring, and other stuff. So now let's see how models can be served. So the serving and the process of getting the result out of model is called inference. So we have two types of inference. The first one is a real-time inference. So that's what you do basically with a ChatGPT. You ask it a question, your data sent to the model, and the model answers you in real time. This is called real-time inference. There is another type of serverless inference which is quite different. So for real-time inference, your model is always up and waits for your request. On the serverless inference, your model can be actually scaled down to 0. When you ask it to process something, it creates a new container. Container is deployed, and your request send it to this model. The second type of the inference is actually batch inference or micro-batch inference. The difference with that is that, for example, inference happens at some cron time, or it not just happens for your only one request. You take a bunch of requests, a bunch of files, a bunch of pictures, and then you process them all together. So yeah, that's how it looks like. So basically you have your input data somewhere in S3 bucket, and you have output data in another bucket. And then and in between you have this model which just activates, I don't know, every day, 4 a.m., takes your input data, process it, and put it back. So on the real-time inference, on the other side, this container is always up. So it's not just created every day, 4 in the morning, but it's always up. It always consumes your resources such as CPU, mostly GPU, and you always pay for it. But it's like accessible in real time. You want to make a request, you do it. Then we have like async inference, where instead of direct access to the model, we use some sort of queue, which allows us to put your tasks, and the model can process it when it processes it. And the serverless inference, which I talked about, yeah, one of the most interesting things we have on SageMaker is actually multi-model endpoints. So inside of one container, for example, you can put multiple models. Why do you need it? So for example, you have a bunch of image processing models. All of those usually requires GPU, but each of them is too small to fill in the whole GPU you have on the virtual machine. So you're just able to put many models into one container and like place them on the same GPU to utilize it most effectively. And on top of that, of course, under one API endpoint, you can have multiple containers, which of them contains multiple models. And here, I believe one of the most useful things in this presentation is actually like the framework how to pick the inference option you need. So as you can see, if you need something real time, and if it's big, you go for async inference. If it's not so big, you just create an endpoint, and in most other cases, you create a batch inference because it's cheap and you don't care. Yeah, so now let's talk about monitoring. So far we created pipeline, we trained the model, we deployed it somehow into SageMaker. Now we have to understand what's gonna happen with it. Yeah, so another meme. So what you want to monitor. So as I said, of course, you want to monitor your code and data. You want to be sure that there are no drifts, that the code is fine, and so on. Of course, you monitor the human interaction and the machine itself. So you want to monitor how users interact and how they use your model. I don't know what API calls they use, what application they use for that. And you want to monitor machine as any machine as itself, like CPU, GPU, EOPS, I don't know, network. So like static and ML failures, so all errors, no big news. Data drift, model drift as a result of the data drift, and system performance. So the data drift starts with data quality. For example, when you try, this is an exactly, so if you remember in the beginning I told you so, example of, let's say, training attack. If someone wants to do something with your LLM, they can try to poison it, your training data. That's why you have to monitor its quality. So you have to be sure that it's complete, valid, unique, that it's like took from right time frame, that it's accurate and consistent. So for that, we have like basically 3 types of monitoring. We have data quality monitoring, so we take drifts. So the most simple way to find the data drift, I don't know, you had the data set, you almost every time you measure like standard deviation, you measure expectation. Then you just set up the trigger that if in your data expectation is changed or variation is changed, you like raise alarm, stop the training cycle, and have to do something with your data. So you monitor violation of constraints, if I don't know. If there shouldn't be any nulls in your data, you have to check for it. And yeah, then when you did this, you go to model quality monitoring. So you start to monitor the performance of your model, both in production and building stages. And then, of course, you have some advanced techniques like bias drift, across sensitive groups. You do some feature attribution, but that's too advanced. So how it works in general? You define some baseline. For example, your expectation have to be 0 and your variation is 1. Then you generate this baseline metric. You add this monitoring metric, and then you just run a monitoring job. You compare a result with a baseline, and if your result is too far from the baseline, then it's an alarm. If it's somewhere close, it's fine. Here are a few things which, like few general architecture, how it works. So you have a training data set, then you do the baselining, you do constraint statistic, you do the job, data monitoring job, and then you send yourself some notifications through event bridge, through cloud, watch metrics, and so on. Here is the same for model quality. So the last thing to discuss here is a feature store. So Are there any data engineers here? Yes, yes. So probably you understand what's that like, right? When you have multiple data sources and you have multiple consumers, so one of the main problem is that you do lots of ETLs, and all of those ETLs, they like snowflakes. So I mean, they quite unique. And every time you have to change some input data here, you actually have to rewrite all of the pipelines. And for example, if there is same pipeline here and here, you probably have a trouble, because if you just need to change input data here but left it here intact, you have like copy your ETL, create new one, and believe me, it quickly becomes a mess. So basically that's why the feature store was invented. It actually allows you to separate the data processing step, or ETL, or other stuff from the consumption of this data. So on one side, you have your data sources, which you just take and do the ETL from them. And all those of your ETL jobs, they actually push it to some sort of the database, which is called feature store. And in this feature store, you actually have the all metadata about it. You can understand where data came from and so other. And then your machine learning engineers, they just take the features you created for them and use them for training. So as model registry allowed us to actually separate the data scientist duties from all other people who want to use the model, the feature store do exactly same thing with the data engineers. So it allows like to abstract data engineers work and just give the results of their ETLs to everyone else. So I mean, here's some features of feature store, and yeah, that's how ingestion works. So we have like data lakes, warehouses, as S3, Redshift, as I said, Snowflake, Delta Lake, which is Databricks and other stuff, lake formation, offline store, EMR, and you just use Spark. We have PySpark or Spark SQL built into SageMaker. Or you actually, as I told you before, you can use Data Wrangler, which allows you, like in the graphic interface, just point and click all of those data processing pipeline. And I actually find it quite useful and powerful tool. So if you do some have to do some data pipelines for ML, try Data Wrangler. It's actually cool. And also try Canvas, by the way. And if you need some real stuff to do, you have to write code, just use Python, Pandas, and do whatever you want. So yeah, here is where you can get some additional resources on SageMaker, on other stuff. So just try it on. If you need more, you can always ask me. And that's basically it. Thank you very much for attention. Any questions? Yeah, so do we have questions? I hope so. Yes. Yes. The lady in the back.
Yeah, hello. Thanks for this speech. Probably I have some weird question, but is there a way to dynamically define a DAX while execution?
A way to dynamically define?
DAX in the pipelines.
So oh, yes, of course. So yes, so pipeline is basically Python code, right? So if you need to somehow, for example, change it in the time, you cannot change it in the runtime, but you can change it before runtime. Do I understand you correctly that you want, for example, build these pipelines depending on some parameters you have, or? Yeah,
actually as in Airflow, so sometimes if I understand that I have a lot of data and I want to separate it to be executed by different tasks, so can I define the tasks dynamically during the DAC execution? So
Yes.
that was the question.
Yes,
Okay.
you can. I mean, of course, you have to code it, right? So you have to code this logic, but yes, you can dynamically define the jobs, you can define the batch size and so on, yes.
Okay, thank you.
Yeah, the man in the glasses to the right.
How it works with authorization? So you showed the idea where you showing the like Jupyter Notebook lines launched. Like how do you authorize on this cloud infrastructure?
Oh yeah. So basically there are two ways. Let's say production and non-production. Non-production way that you just authorize directly from your AWS console. And the production way is actually all of this is integrated with AWS IAM Identity Center. So basically, as SageMaker has the full governance tool set inside of it. So you connected to Identity Center. Identity Center connected to some identity providers as Okta, Active Directory, or any other, right? And then just right, you would use Identity Center to log in into AWS. You use it to log into SageMaker, then you use all the groups from Active Directory and match them with existing roles, existing access controls, and so on. Yes?
And one more question. Am I right that all of this running only in AWS Cloud, so no kind of self-hosted versions of it, so it's like purely in the cloud?
There is a local version of SageMaker, but it mostly for debugging purposes and local development. And yes, it runs on AWS Cloud, but some parts you can actually take out. For example, if you have your own supercomputer for training, right? Inside of SageMaker, you can attach any Kubernetes cluster to run your training jobs, your inference jobs, your data processing jobs. And in this situation, it goes like you have, let's say, control plane inside of AWS, right? But you can send the actual jobs to be executed on your Kubernetes cluster. Yep.
Hi. My question is more like data frequency. You mentioned you train like data for 3 months and then it becomes like outdated. What if you have like daily changing data? How do you tackle that?
Well, I mean, but the question is like, it's not only about how frequently your data change, right? But it's about how often your business requires you to retrain the model. So for example, if your data changes every day, but you see that the data is stable, there is no drift, right? So it's already stable data flow. You don't have to retrain the model every day, let's say, right? But if in some cases, so for example, if you do some sort of, I don't know, automatic machine for recognizing X-ray pictures, right, of the patients, you probably will not retrain it every day. On the other hand, if you have online casino and you're building a recommendation system for a user to keep their interaction on top, right, so you probably will just take the fresh data from today and retrain model every day. I mean, 3 months is just an example of how long does it take to train ChatGPT-like model, right? So big, large language model. For some simple models, they can be trained sometimes in minutes, sometimes in hours. So it depends on the models, it depends on the algorithm, it depends on your business task.
And another question, do you really train the full model or you like fine tune based with your data?
Oh, you mean for LLM?
Yeah.
So, I mean, I've trained my own model for educational purposes, of course, but in real world, you most likely do either retrieval augmented generation without any fine tuning. The next step you will try is fine tuning, different techniques. If fine tuning is not enough, you start with continuous pre-training. It's more powerful thing than a fine tuning, which allows you to change the probabilities of the LLM even more. And if even all these three, let's say, approaches didn't help you, only then you start to train your own large language model. Okay, yes. Third row, headphones.
Thanks, Nikita. I think yeah, we can do without microphone. So I know nothing about SageMaker.
Yep.
Yeah, but I've seen on some slide there was Bedrock.
Yes.
What's that connection or relation, if any?
Yes, sure, sure. So let me. Oh, it's gonna be too long.
Yeah, it was very good.
Yeah. One moment. Yeah. So basically, Amazon Bedrock is a service where you already have models available to you through API. So for example, it's the same as, I don't know. So let me just show it probably. Why not? So SageMaker is a service which allows you to use already trained models which you don't even have to administrate, host. You can just use them. So like, for example, you would use OpenAI API, right? ChatGPT. So Bedrock is the same. The difference that in the Bedrock, we have plenty of different models. So we have models from Anthropic. We have models from Meta. We have Mistral models. We have Cohere models. Of course, we have our own models. And all of that accessible to you through API with some, of course, added value services on top, like out-of-the-box knowledge bases, out-of-the-box agents, out-of-the-box security protection as guardrails, watermarks detection, because, so for example, every model which is generated with a Bedrock, every image which is generated with a Bedrock, automatically watermarked. And in future, you can check this image if it was created by Bedrock. Yeah, so here you can see like all of the models we have. Of course, I mean, most popular ones are the Claude family and Meta family, or like Llama 3 now. We have Llama 3.1 and Mistral, of course, those one. And the like connection of the Bedrock with SageMaker it's actually quite simple. So here you can see I have imported models. So for example, I want to fine-tune some model. I can fine-tune it or any other way customize this model in the SageMaker, and then I can import my own model which I customized like I needed to do so into SageMaker. And then you don't have to administrate it. You can just go straight away and yeah. Yep. Any other, yeah.
And one more question. So now it's very popular, reinforcement learning with human feedback. Does your pipelines support integration of human feedback into the training?
Yes, actually, yes. We have a thing which is called SageMaker Ground Truth, which actually allows you to implement the human pipeline. And more than that, our pipeline can be human controlled. So for example, if you want to be sure that model will be deployed just after some person take responsibility for it, you can also add it by pipelines. But yes, what you are asking for is a SageMaker ground truth, which allows you to include human into this pipeline cycle, so you can do relabeling of the data and the results and reuse it somehow, so it's up to you. I mean, it mostly looks like some Yandex Toloka, but not so good. Okay, any other questions? So from what I understood, I should do generative AI session, right? Okay, so no more question, right? Yes.
Does
I mean, it's quite abstract definition of geospatial data. Yes, it supports geospatial data. There is like SageMaker Geo, which have special models. It has the geospatial data, but I mean, basically so it has some, let's say, built-in already coded tools for geospatial. I'm not an expert, but we can look together after session. I will show you some links. But anyway, like even if it wouldn't, let's say you have Postgres SQL probably, right? Inside of this Postgres SQL, you have PostGIS extension where you store your geospatial data, so it can connect to your Postgres, so yeah. But it has some special stuff for geospatial, definitely.
Yeah, thanks.
Yes.
I have something which is not a generative AI. I think.
Uh-huh.
It's an application where users can, surgeons, it's a healthcare thing where surgeons can upload an image and get a response back on how good the image is for transplant.
Mm-hmm.
And the build side is done offline, completely outside of AWS, and the ops side, the inference stuff, is done in AWS.
Okay.
And I can see some of the things that you described about SageMaker, for example, the data, the monitoring, the model monitoring,
Yep.
all of those things are things that we have to ask the development team for, and get them manually done.
Yes.
And that would be much better if it was in something like
Yeah, I mean,
SageMaker.
you should definitely, in that case, I mean, that's a no-brain just to try SageMaker and implement it into your cycle. And as I said, so you can keep the control plane of your operation inside of SageMaker. You can connect your on-prem Kubernetes cluster to SageMaker and still do the training on your on-prem cluster. So I understand you probably have some sort of MLOps racks out of there to train those images actually, or how it's called now, InfiniBand, I believe. It's not MLOps anymore. So, and that's why you can just not bring it to the cloud easily. So you can deploy Kubernetes out of there, connect this Kubernetes to SageMaker, and keep the build part out there, and take all of those pipelines, monitoring stuff on top of it, like for cheap.
It was a really nice talk. Thank you. And I enjoyed the memes.
Thank you. Oh yeah, and also like there was a QR code, so please fill in short questionnaire because we're, let's say, evaluated as solutions architect also on giving such talks. So please scan it, fill out the few questions. I will be really grateful for that. So, okay then, any other questions? Well, I guess that's it then. Thank you very much for attention and see you next time.